Okay, so suppose there are a group of 10 friends. Notice how I named these friends. Adam, Brian, Carl, Dave, Eddie, Frank, Gavin, Heath, Ivan, and Jeff. First initials, alphabetical, A through J. A, B, C, D, E, F, G, H, I, J. Out of these people, Adam, Carl, Eddie, Gavin, and Ivan are on the football team. Also, Adam, Brian, Carl, Dave, and Eddie are on the baseball team. Fill in the Venn diagram of these 10 friends. I think you guys have seen a Venn diagram before. Am I right about that? Like with the circles and all this. What's this place called right in here? That's the what? That's the intersection of those two sets, you know, like that's where football and baseball like intersect each other at. So, and then the whole outside rectangle though is something that you might not be familiar with, because everything in green is where football players can go, and everything in the red circle is where baseball players can go. But would you believe that not everybody in the world has to be a football player or has to be a baseball player? So that's all the stuff inside of the blue. It's just like, okay, maybe you don't belong in either one of those sets. So fill out the Venn diagram for these 10 friends. There is definitely lots of ways to do this. I personally go find the intersection of these groups first. So here's all of my football players: Adam, Carl, Eddie, Gavin, and Ivan. They're all on the football team. Here's all of the baseball players: Adam, Brian, Carl, Dave, and Eddie. Discuss with neighbor who's in both. Who's in the intersection? Discuss that, please. So we've decided Adam's in both sets, and you said Carl's in both sets, and anybody else? Eddie. So let's put them in the intersection. I'll just throw their letters: Adam, Carl, and Eddie. That's why I named them so specific, so we don't have to write all their dang names down. Are you okay with that? So Adam, Carl, and Eddie are in the intersection. Well, then that means we could go to the football team and put everybody else in the green circle, but not in the intersection. So Adam, Carl, Eddie. Would you believe that Gavin is on the football team but not playing baseball at the same time, and Ivan is on the football team? So he goes in the green circle but not in the intersection of those two places. Sound okay? Put the rest of the baseball players over here, the ones that are not in the intersection. So Adam's in there. We need a Brian. We got a Carl. We need a Dave. And Eddie's in there. How many friends total was there, though? 10 friends. We count up all the letters. 1, 2, 3, 4, 5, 6. I lost. 1, 2, 3, 4, 5, 6, 7. We're missing some people. Who are we missing? Who's not like a baseball player or a football player? We got Adam. We got Brian. We got Carl. Is Dave in there somewhere? Yep. Eddie. We got him. Frank. So Frank can't go in the red circle and can't go in the green circle. He definitely can't go in the intersection. So Frank is in there somewhere, but he's not inside of any of the circles. So took care of Frank. Gavin is on the football team, so he's there. Heath, we didn't talk about Heath, so Heath is in there somewhere. Ivan, he was on the football team. And Jeff wasn't on any team. So there's all 10 of them then. We got 7 people in the circles and 3 people outside the circles. There's all 10 people. Out of these 10, who is on the football team and the baseball team? I'll let you discuss, then I'll call on somebody. Yep, Adam, Carl, and Eddie, or A, C, and E. If this was a homework worksheet, we'd write their names out, but since it's practice, I'm fine if we just put the initials in that case, A, C, and E. And where on the graph, on the Venn diagram, was the answer to this? Anybody? Where were we? In like the, what is, it's in here. What is this place called? That's in the intersection. And is a fancy way in mathematics to say the intersection, because you're on both of them. Which of the 10 are on the football team or the baseball team? So football or baseball. Would you believe that's everybody in the green circle, everybody in the red circle, and everybody in both? Right? So how many of the 10 are there? Out of the 10 people, how many answers are there? There's 7 of them. It doesn't matter what order, but G's on there, I's on there, A, C, E, B, and D. Probably made more sense if we put it alphabetically, but I think we get the idea. 7 of those 10 people were on either the football team or the baseball team, or is the fancy way to say the union of those two sets. If we united the entire football team and we united the entire baseball team, we'd get all 7 of those people. If I asked them, like let's say they were people in this room, these 7 people, and I asked them to go stand in the hallway, I'm like, hey, Gavin, you go in the hallway. Hey, Ivan, you go in the hallway. Hey, Adam, you go in the hallway. Carl, go in the hallway. And Eddie, go in the hallway. When I started listing all the baseball players, when I said, Adam, go in the hallway, if he's already in the hallway because I listed him as a football player, can Adam be in the hallway twice? If I said, I need all the football players to go in the hallway, so all of these guys go. Adam goes, Carl goes, Eddie goes, Gavin goes, Ivan goes. Then I say, all the baseball players need to go in the hallway also. Would these three people have to go out there twice? Or would they just say, dude, I'm already in the hallway? What do you think, twice, or they're already there? They're already there. So you can't be in the union twice in that system. Like when you unite them all together, it's just like list everybody that plays only football, everybody that plays only baseball, and everybody that does both. That's the union of those. So here's the symbols. The and symbol, it's the intersection symbol is what that means, and it's like an upside down U. But I think we talked about the union symbol last time, you know, when we did our set notation. The union symbol looks a lot like a U. That's how I remember union, U. But we need to remember that union symbols are OR statements also. So let's dive in. Mathematically, the word AND means this and OR means that. We just talked about it. Here's set A. These numbers, 1, 2, 3, 4, 5. Set B, be these numbers, 2, 4, 6, 8, 10. What is this? Tell your neighbor what this symbol says right here. Then I'll call on somebody. This totally says what is A intersection B. So since they use fancy schmancy set brackets, we will use fancy schmancy set brackets. And we got to list everybody that's in the intersection. That's both at the same time. Just like back here, that was the people that played football and baseball at the same time. Right? The intersection is people that's in set A and in set B. So would you believe that is 2 and 4? Are you okay with that? It's just 2 and 4. 2 is in both sets. Boom, boom. 4 is in both sets. What does this say? A what B? What's that symbol mean? A union B. That means everybody in set A and everybody in set B, put them together, but don't list them twice. So we list all of A and all of B. So all of A, 1, 2, 3, 4, 5. And then I'm going to go listing people in set B, but not anything twice. So I don't need to again. Again, aren't they already in union in that case? But I need a 6, I need an 8, and I need a 10. How do you feel about the union versus the intersection of two things? Union, put them all together, don't list anybody twice. Intersection is what's in both of them, common stuff. So let's get real right here. 200 people were surveyed about chocolate or vanilla ice cream. 150 people like both flavors, while 3 people say they do not like either flavor. If 173 people like vanilla, how many people like chocolate? Woo! Too much information to read that all at one time. Here's what we're going to do. They're talking about two different things, either chocolate or vanilla. Let's go label our circles in the Venn diagram. Let's call one of them C for chocolate and one of them V for vanilla. How do you feel about that? How many people total surveyed? 200. So in all of the stuff, the intersection, the unions, even the leftover group, there'll be 200 total people. Sound good? 154 people like both flavors. This is probably the easiest thing to put in the picture. 154 like both flavors. Where does that go? In the little, what's this called again? Intersection. 154. Would you be cool that 154 people like chocolate and 154 people like vanilla? Right? They like both. 3 people say they didn't like any flavor. They didn't like chocolate. Where do those 3 people go? Inside the circles or outside the circles? Outside. But they're in the rectangle, you know. They're in that because they were people surveyed. So the rectangle is all the people surveyed. 173 total people like vanilla. Let's call it this orange circle. 173 total people liked it. Well, 154 of them said they also like chocolate. Could you figure out how many are left over that only liked vanilla then? 173 total people said, yep, vanilla's good. But 154 of those 173 people said, yeah, I also like chocolate, you know. So what could we do mathematically to figure that out? Subtract them. Take 173, take away 154. And I need you to help me out. How much, Mason? 19. Do you guys agree with that? So 173 total people liked vanilla. 19 of them said only vanilla, and 154 said, oh, I like both. How many people like chocolate? That's what we got to figure out. I'll pause here. I'm going to record that. So we have decided that you take all 200 people, that's how many people surveyed, and to fill out this, we just subtract 200 minus this, this, and this, because that's what's left. And what'd you get, Dalton? 24? Is that what we're coming up with? So the reason why we could do that with the vanilla stuff is because these 173 people, we knew that they only liked vanilla. So we were involved in the orange circle, 173 total, take away the intersection. So I'll let you answer these two questions. What is C fancy symbol V, and what is C fancy symbol V? Make sure you're reading the fancy symbol to yourself. Is it a union or is it an intersection? This says, what is C intersect V? That answer is it the 24, the 154, the 19, or the 3? What do you think? 154. There's 154 people in the intersection of those two groups. And then what does this say? This is the union. So there's a lot of ways to figure out the union. You could add up the 24, the 154, and you add those all up. Or, you know there's 200 total people, and do you know how many people are not in this group? In these three, do you know how many people are not in this group? Just 3 of them. So if there's 200 total and only 3 of them didn't like it, would you believe out of the 200 people surveyed, 197 people said, yeah, I like one of those flavors of ice cream. You know, the union is everybody who likes chocolate only, or anybody that likes vanilla only, or anybody that likes both. Right? It's putting it all together. There's only 3 people that didn't say they liked any of those flavors. So the union is just the 197. But the 200 is the total people surveyed. Does that feel all right? Okay. Let's try it here. Use a number line to find all the values of x that x is greater than -4. Woo! Underline or circle, whatever you like to do. And x is less than 3. Let's graph both of those as what I call helper graphs. Please do not put them on the number line, put them above the number line. X greater than -4. Open dot or closed dot? Open dot goes to the right. You cool with the red dude? That is x greater than -4. We're just putting him above the number line though, because he's going to help us figure this answer out. X less than 3, so that's going to be here with the open dot. And less than goes to the left, to the left, to the left. And then we just need to know what and means. Does and mean the union, or does and mean the intersection of those two graphs? I will give you a phrase that we're going to use next class period with our absolute value inequalities. If it helps you, you might want to write this phrase down. Dis, union, greater than, or. You may have also heard that before from your Algebra 1 class if you took Algebra 1 here at Hayes High. Dis, union, greater than, or. It's all a bunch of acronyms, you know, like I did with really quiet zebras won't neigh and all that crazy stuff. Dis stands for disjunction. Union means it's a union symbol. Greater than means it's a greater than symbol. And or means it's an or statement. I just made it up because it sounds like the English sentence, this union is greater than yours. You know, like if you were trying to battle someone from another country, like the United States is our union, you know, that's our country. This union is greater than yours. Dis for disjunction, meaning the pieces are in 2 separate pieces. Union for union. Greater than, because you'll see that next class period, it's using greater than symbols when we're doing absolute value. But or statements and unions go together. Since this is an and statement, do you feel it's a union or an intersection? Intersection. Where does the red graph and the green graph intersect? Would you believe that's in this region that I'm highlighting pink? Isn't that where the red part and the green part are right on top of each other? So you bring that guy down to the number line. There's an open dot right here. There's an open dot at 3, and that's in the middle. This is the intersection of those two graphs. The intersection of those two graphs. Let's see if we can write that in set notation. That's what they want, part A. It's a set of all x's, because that's the letter they were using, such that. And then when you look at the final graph, if I cover all this other crap up, and I look at the final graph, just the thing we put on the number line, isn't that just one piece right there? One piece. Not two pieces, one piece. But it's got two boundaries. Those and statements that have two boundaries, those are the weird guys where x has to go in the middle and the symbol has to be pointing to the left. And we put the smaller boundary on the left side. That would be -4. Isn't he the most leftern boundary in that case? -4. And the bigger boundary on the right. Set of all x's such that x is greater than -4 and at the same time less than 3. This is an and statement. Let's put her in interval notation. That's what the brackets and the parentheses. So if I read from left to right, if I start way over here at -infinity, is that straight edge touching, is the green thing touching my straight edge over here at -infinity? Nope. Wouldn't until we get to where? -4. Included or not included? Not included is correct. Is that a bracket or a parenthesis? Parenthesis. Move to the right. It's touching all the way over to 3. Agree with that? The 3, since it was an open dot, he's not included either, which is a parenthesis. Awesome. So let me see if I try this. We did all that for compound inequalities. Compound inequalities is you'll see an inequality where there's more than one inequality symbol in the picture. So like here, there's more than one inequality symbol. Here, there's more than one inequality symbol. So we need to know if we need the union of those two sets or the intersection. So maybe notes at the top is unions are or statements and intersections are and statements. Just kind of notes for yourself at the top. If they mention an or statement, we need the union of these two helper graphs. And if they mention an and statement, we need the intersection of those two. I like to look at number 6 first. Can you totally tell that number 6 is an or statement? I mean, it's just it's literal, right? You know, it's like, hey, it's this one or this one. It literally says or in it. Number 5, though, is an and statement. The way you can tell is because it's one of those wacky compound inequalities where they got stuff in the middle and they got two different boundaries. We're going to do this the long way because it's the right way. In college algebra, you can learn a faster way for it, but let's do this the right way. We've got to set this up as two statements. So if you don't have to put this box, but if we take what's in this box and put it over here to the left, this says 2x plus 5 has to be greater than or equal to -3. That's the hard one to understand because it's written backwards. Then we'll throw a word in the middle. I'll give you a choice. Do you want me to put or do you want me to put and? What kind of statement is this, an or statement or an and statement? It's an and statement. So word in the middle. And then you take this guy. You take the middle dude, the 2x plus 5. We didn't switch any symbols or anything like this, but the 2x plus 5 is kind of used twice because he was in the middle. And all we got to do is solve both inequalities. So let's roll with the blue one. Subtract the 5 over. That's -8. And then divide by 2. Does the symbol switch if I need to divide by 2? Symbol switch? Does not. Even though we got a negative result, it's about if you multiply or divide both sides by a negative. Well, I hate this guy. He's all Johnny backwards. I don't like it like that, so let's pull the old switch on him. Let's bring the x over here and the -4 on the other side, but that means you got to switch the symbol to make it equivalent. So it was like a less than or equal to, we're going to turn it into a greater than, because I switched everything around. Both of these say x is greater than or equal to -4 in that case. Okay, but I like to turn this one around so I can read it correctly. Red one, piece of cake. Solve the red one. Dun, dun, dun. So I got me a nasty little, is that right? 14, thank you. I don't know what I was thinking. I was just brain farting ahead. So thank you, my bad. All good now that I've fixed my mistake. Okie dokie. So let's graph both of these as a helper graph. We need both of them up top. Do not put them on the number line, so x greater than -4. That's a closed dot if my pen would wake back up. And going to the right. Sorry, my pen froze. And then x less than or equal to 7. That's the red dude. Since he's in no man's land, I'm going to literally put a 7 up by this dot right here. And throw him going to the left. And then I got to go back and use the word to see if I want the union or if I want the intersection of these two guys. And is the word. Does and mean unite them together and put all the blue and all the red together and everything that's in between? Or does it want the intersection that just wants where blue's on top of red? Union or intersection? And is an intersection of these two graphs. So that is right here in this highlighted region. Just, isn't that where blue and red are right on top of each other? So I said we bring that down to Chinatown. That comes down to the number line. We got a closed dot here, because that was a closed dot. We got a closed dot here. Throw a 7 by it also, since it's in no man's land, and everything in the middle. If you think that all and statements look like this, that's a good thought, but they don't. Not all and statements end up looking like this. You'll see that next class period. That's why we're doing all the work. And it's like, well, shouldn't and statements always just be that thing in the middle? I'd say 99% of the time, but not all the time. Let's put that in set notation and interval notation. Set's the weird dude. Set of all letter they were using X's, such that. That's when you did all of that work just to see this damn thing. That's all you care about now is just reading this like we did last class period. This is where we need X in the middle, symbols pointing to the left both times. Because it's got two boundaries. One statement with two boundaries. Decide if I need equal to bars on the left side. Do I need an equal to bar right here? Yes, that's a closed dot. Do I need an equal to bar over here? Yes, that's a closed dot. Smaller number on the left, bigger number on the right. Close up the set. Every single time when you have a graph looking like this, X is in the middle, symbols point to the left, you just got to decide if you need equal to bars or not. Smaller number, bigger number. Interval notation, I think we got that down, bro. Doesn't that go from -4 included to 7 included in that case? Is that all right with you? Cool. That was the sucky one. Those were and statements. The next one's an or statement because it literally says or. So it's already set up. Let's just solve them both for y. Solve the left one, solve the right one. Please pause the video and solve them both and then check back with me. This is what I got with my algebra. I never had to switch the symbol because I never divided either one of those by a negative. Then graph them both as helper graphs. Y is greater than or equal to 3. So I'll go to 3. I'll do it in green also to keep myself color coordinated. Closed dot. Boom. Put a 3 since 3 is not on a tick mark. Less than or equal to -4. Helper graph. And then we got to decide what to do with these helper graphs. It's all based on the word. Do we want to unite them? Or do we want the intersection of these two graphs? Or union or intersection? What do you guys think? Union. So that means everybody in blue is invited to the answer, and everybody's in green is invited to the answer, and even anybody that's blue and green at the same time, which there's none of that, right? But everybody in blue comes down to the final answer, so that's him. This is all the blue stuff. Everybody that plays football, and everybody that plays baseball, and everybody that plays both. It just so happened that nobody played both when it came to blue and green in this situation. But the union of those two sets is all the red, and all the blue, and all the green, which turned out to be the red. Writing the set notation is pretty easy. Set of all, watch the letter, I just wrote X, but it's Y's this time, so watch out for that. Set of all Y's such that you just take these two answers that you got and put them in there with the magic word in between them. Y is greater than or equal to 3. What's the magic word? Is it or and? Or y is less than or equal to -4. Or statements, piece of cake. Put them both in there. And let's do our interval notation. You could follow my straight edge here in class, only looking at the red answer. Don't care about any of this other stuff. We did all of that work just to get to this red answer. If I put my straight edge over here at negative infinity, would the red thing run into it way over here at negative infinity? Yes or no? Yes. So, I'll get my pen back. From negative infinity, which always gets a parenthesis, remember that? And then we move to the right. It would touch until we got to what critical value next? Negative 4. He's got a closed dot, so that gives us a square bracket. And then I got to bridge this gap in the middle. What symbol bridges the gap? The union, because it literally means or in this situation, or from 3 included to infinity. Sound all righty with that? These have to be in this order also. You cannot switch these two groups around and say from 3 to infinity, union, negative infinity to negative 4. It doesn't work that way. You got to go from left to right. So that's not good in that case. From left to right. Okie dokie. I'll turn you loose after. You can tell me if this is an or statement or an and statement. What do you think? Or statement or an and statement? This is an and statement because it literally doesn't say or. Split them up. 100 less than or equal to 5y minus 45. Throw and in the middle. And then the other guy is 5y minus 45. That weird middle group gets written twice. 225. But you handle this dude, and then you handle this dude. Graph them both, and do the intersection of those two graphs, because that's what and means. So please pause the video, get that done. Did my algebra. Got these two. Remember, we're going to turn this homeboy around. Then I'm going to graph them as helper graphs. Made my helper graphs. Had to put the specific numbers of 29 and 54. And statements mean I want the intersection. That is right here, bro, where the green one and the blue one were right on top of each other. So from 29 included to 54 included, and everybody in between. Put them on the number line also, those specific numbers. Set of all y's such that y's in the middle, symbols point to the left. I need the equal to bars both times. 29 is the smaller, and 54 is the bigger. That's literally how I say it to myself when I write. It's like y goes in the middle, symbols got to point to the left. Do I need the bars? Yes, I do. And then 29 included, 54 included. Awesome. Feel okay? One more. Please get that done. Here's my algebra and my helper graphs. And or means I want the union of those. So that means bring down all the red and all the blue. 5/2 is like 2.5, so that's right here in between. And you would think that it's like, dude, like I thought all the or statements look like this, where they're pointing out both times, and all the and statements meet in the middle. I'd say like 98 to 99% of the time that will happen, you know. But there are some weirdo cases where that won't happen, and we'll see that on our next couple problems. Set of all k's such that k is less than -3, or k is greater than 5/2. These you can switch the order of those around. Like if you had these two moved around, it really doesn't matter. And then the interval, just read that green graph. It's going to be a long day if the pen doesn't want to cooperate. Not included, union, 5/2 to infinity. All right, let's see what happens when things are weird. They don't have us do any algebra. It's all solved. X is by itself. But they want us to graph this or this. So let's do helper graphs. X greater than -1, greater than or equal to, excuse me. That's green, bro. X greater than 3. They're both pointing the same way. That's going to happen when we do some weirdo stuff next class period also. So it's kind of like just coaxing us into it. We've got to know what or means. Tell your neighbor, union or intersection? What do we want with those two guys? Union. I'm going to bring down all of the red one and then all of the green one. I'm going to do them in separate colors. Actually, sorry, I'm going to do them at a separate time but the same color. Just kind of watch me. All the red one has to come down. How do you feel about that being all the red one? Right. And then all of the green one has to come down. And the interesting thing is when the green one comes down, he fills in that open dot right here. This open dot ceases to exist anymore because that green one covered him up. So here's what the graph looks like. It is just this blue dude. Cover all this crap up. And let's write that in set notation and interval notation. Would you believe there's only one arrow in that situation? So it's the set of all x's such that. And you know what that says. We did that last week, you know. X has to be what? Greater than or equal to -1. This dude took care of all of it, right? If I said that you needed to be either older than 18 to vote or older than 25 to vote, doesn't older than 18 just kind of take care of all of it? It was like, well, why did you even say the other part that you had to be over than 25 to vote? It's like, yeah, that works because all you got to do is got to be 18 or over to vote. So they like kind of repeated themselves. So that's from -1 to infinity. Why don't you and a neighbor get the last one done in that case? Graph both of them as a helper graph and use the word and to do either the union or the intersection, whatever it's supposed to mean. Section. So we do the intersection, and the hard part is finding the intersection. That's where the blue one and the red one are on top of each other. And would you agree that that's where I'm highlighting in orange, where the blue one and where the red one are on top of each other? It's kind of like this weirdo bit right here doesn't even matter. It's like you have to satisfy both of these. You have to be on the red one and the blue one. So that means we're going to bring this down, the orange region, which truthfully is just the blue one. You have to use the open dot still and go this way. And when you intersect graphs go in the same way, it's like you just have to be the most specific one in that case. So that's the set of all x plus -2. And that went from -infinity to -2 not included. This part right here doesn't satisfy both of them, right? If it's like, let's just say, to go buy alcohol, you have to be 18 and 21. You know, it's like we have to make both of those true. So don't you pretty much have to be 21 to do that? It's like being 18 doesn't work. You know, it's like, well, I'm 18. No, you have to make both of these true. You have to be 18 and at the same time 21 and over. And it's like the only way you could do that is to be 21 and over. So it's kind of wacky. Trust in the helper graphs and trust in the union and the intersection concept. Cool. And if you need help, let us know. Have a good one.